All right, let's get started. So this is problem number 45? 45, I think, actually. Longest substring without repeating characters. Number 3 on LeetCode, a medium problem. Given a string S, find the length of the longest substring without repeating characters. Note that the answer must be a substring. PWKE is a subsequence. Okay, so substring contiguous. In case I forget this myself, because that could very much be the case. So, one thing that you could do is, so the naive approach, a sliding window without modification. So start with a sliding window of size 1. Then for each element in the sliding window, and create a set for the iteration, or a global one that clears. Then for each element in the sliding window, check to see if it's in the set. If yes, then we need to... That's a good question. That is a good question. Just thinking now actually how to do the naive approach. I thought that it was a pretty straightforward one, but that's because we need to expand the sliding window essentially if it works. If yes, then we don't expand the sliding window. If no, then expand the sliding window to one element forward. The question then becomes sort of how you would do this, because even in this naive approach, I'm not even quite sure actually how to completely do it. Basically, you start at A. For each element, it's not in the set. Okay, so you expand it to B. And then you rerun algorithm, I guess. So you do A, and then AB, and then ABC, right? And then ABCA. Maybe you just check to see if the last element... That's a good question. Basically, you could check to see if the next element, if you can take it. Or you can just expand. If it doesn't, then contract sliding window by 1. So we expand ABC. We expand one more. It doesn't work. Contract. And then we slide over. Recording max size? This is an interesting question. The question really is that we're doing a lot of additional work by not, or by repeating the amount of work to record the values that we have. Pretty much. So basically ABC, we know that BC is, like if we slide this over now to BCA, we know that BC is still in our train, or in our window, but we still sort of recount it in this sort of situation. Instead, maybe we can just remove elements at the head of our sliding window when we pass them. So basically ABC, when we slide over to BCA, we remove A, and then we slide over. Okay, I think that seems reasonable. So we just create a set. We create a set. We start with the sliding window of size 1. We create a set for each element in the sliding window. We first check to see if it's in the set. If not, then we add to our set and continue. And this could realistically be like a, this could be like an array of size 26 with offset determined, or index determined from offset from A as a lowercase character, because it seems like, oh, it contains English letters, digits, symbols, digits, and spaces. Okay, then, yeah, nope, we need to do a set. We need to do a set. There's a lot of symbols to worry about in that case, yeah. And we have to assign them like a value. That's a little bit too much. Though maybe you might be able to get away with everything in the ASCII alphabet, in the ASCII table. Then in that case, you could have a, you could do O1. O1 is probably possible with the ASCII dictionary, but it's a bit of work. Then for each element in the sliding window, this is actually, no. Add the first element into the set within our sliding window, and then expand. So we expand to size 2. And add, or actually before, check the next element. If it exists within our set, we slide over. If it does not exist within our set, we expand our sliding window. I'm not actually sure if this works, but this is just, maybe this works. So if it doesn't, or if it does exist within our set, then we slide over, basically to attempt to in the hopes that it's at the beginning of our set, we slide over. And if it does not exist within our set, we expand our sliding window and add to set. So this will be A, and then the next element is B. It's not in our set, so we add it. C is also not in our set, so we add it. A is in our set, so we slide over. And then when we slide over, before we move, remove the first element within our window, so left, from our set. So A, B, C. A is already in our set, so we slide over. So B, C, A. We slide over, and then we check again. That's a good question. Because we could potentially have a string like A, B, C, A, D, where this ABC starts off expanding. A, again, then we slide over, so BCA. And then CAD. And then we expand to D. We slide over, so while the item still exists within our set, continue sliding and remove the first element. So basically we just slide over until the element is no longer... no, but the element will always exist within our set. Because we also include the other one. That's a good question. We sort of have to make sure... How do we make sure that we... Continue sliding until it is the first element in our set, or in our window, and then once more. Basically, if it's something like A, B, C, B, right? We start with A, B, C, then we see we have B. B is in our set. We slide until B is on the left, and then we slide one more and remove it from our set. So we slide until it is our first element, and then once more, removing item from our set afterwards. The idea is that we don't know where the first element is within our set or within our window, but we can slide until we get rid of it, or until we hit the end with our right side, at which point we know that we can't make another longer array. There's also a small optimization here that... No. I was gonna say if the substring is over the over halfway, then we know that it's the longest. But no, the longest substring could technically be the entire array or the entire string, and we might not know. But yeah, the idea is that we don't know where the first element is within our window, but we can slide until it is, or until we hit the edge. And if we hit the edge, then we know that there cannot be another sub-array that is longer, that includes what we have so far, pretty much. So, I think this is a pretty decent solution. Let me think. Start with a sliding window of size 1. This is O of 1. Empty set, this is O1. This is talking about runtime, not space. Add the first element, that's O1. Checking the elements. Okay, let's see. in the case we have a situation where in the situation that we have that we had to check all of them, right? We have an upper or a lower bound that we had to check all the elements in case each element is unique. In that case, it will take O of n time. Then, if we have this sliding is just moving elements, and this and we only really check one element, and that's the left element in our continuous substring. So there's not much of an increase in runtime there, at least on an asymptotic level, right? We're still just checking the left edge of our substring. We're not checking our entire substring. Now, it is possible to probably do the solution in a very similar manner by checking the entire substring and not keeping track of the elements. But then we would have, at that point, we could potentially, if we had, let's say, a completely like A, B, C, D, E, you would do check 1, then check 2, check 3, check 4, and then check the entire string, right? And then that would be, in that case, that would be polynomial time. However, in this case, we don't know where it exists, but this is a bunch of extra work because we know that the string will only be unique when we expand into a space. We know that the substring is unique. If the substring is not unique, then we slide over, and we don't know where exactly the conflict is, but we know the letter that we want to get rid of. And we know that if it reaches the end, if it reaches the head or the left side of our substring, and we move over one more time, then we will get rid of it. In that case, then that's how we sort of get rid of the asymptotic, the polynomial runtime, because we only really care about sliding it over until we hit either of the two conditions. So I think this may be an O of n solution. Of course, there are some additional caveats here with the constant multiplier because we're always checking the left side. So I think you could argue that it is 2 times O of n or O of 2n, but ultimately, asymptotically, it seems like this is an O of n algorithm, as far as I can tell at the present moment. So I think this is a decent enough solution. O of n space, because ASCII is weird. So let's get started. So let's start by saying var left is 0. Var right is equal to s.size minus 1 because we're dealing with a string, not a collection. Actually, no. Var right is equal to also 0. Then we can say val character set is equal to mutable set of char that starts with s at 0. So s can be actually a length of 0. So if s.size is 0, we can return 0. If there are no strings or no characters within the string, then obviously there is the longest substring without repeating characters is size 0. So now we know that at least that there is one element within here. Then we can say while right is less than s.size. So it goes all the way up to s.size minus 1. If right plus 1 is less than s.size and character set get or null s get at or s at right plus 1 is equal to null. So if it actually I think we should actually do this. We split it up because this, if right plus 1 is less than s dot size, if it's not greater than that, then we just slide it over. Actually, I'm not sure. We'll leave it like that for now. This might have not been actually a wise choice, but we'll see. So if the character set of the next character does not exist, then we can say right plus plus. So we increment on the right. And this is only if the adding one, if the next element is obviously still within the confines of the string. So we won't get a null here and then just go on forever, right? Or like we won't add in a random null. So we increment here, or set add s at right plus 1. If it does exist, then while while s at our left side is not the value that we want, s dot right plus 1, we can say here val our next character, so it doesn't change, right? S right plus 1. And just to make it a little bit more clear as to what we're doing, so while our left side is not the next is not equal to the next character, the same as our next character, we want to do a left plus plus and a right plus plus. And then before we actually do the left plus plus, we're going to do a character set get or remove s left, because we know that that character is going to be in our list. Or in our set, rather. And then what else? Let's see. And right is less than s dot size. Actually, we can just do character set get character next character or null is not null. So while it still exists within our set, we're just going to remove whatever's on our left and increment and slide our window over. And obviously our right window hasn't exceeded. And at the end, once we do this, let's see. The problem now is that when we slide this over, we aren't keeping track of other elements that enter our space. Which is a problem. So we kind of need to do this for every single character that enters our space. So when we slide over, we need to be really careful. So, because like ABC, right? This A is obviously here. We slide it over. That's fine. We expand again, but our next character is B, which is already in here. So we expand again. But if we aren't careful, we might get to a point where we inadvertently introduce another element within our space. Another duplicate of a different character, which is not what we want. Which is bad. For hopefully obvious reasons, but how do we get rid of that then? This one is tricky. It's specifically this part that is tricky. Because we don't want to just worry about the value that we have right now. We also want to worry about the other duplicate elements. Let me think about this some more. I'll be right back. Alright, bathroom break over. I kind of thought that maybe we could use a map instead. The reason why is that here, what we do is that rather than doing this, let's see. The idea is that rather than just having a sort of O1 approach, consider storing frequency. So when we encounter a new or a duplicate character, increment the value and slide. But what does that actually let us do? When we encounter a duplicate character, we increment the value and slide. At the head or left side, we lower the value or the frequency. I guess the idea is that sliding window still stores a record of what we have, or our longest string. Sliding it over and adding the frequency just makes sure that we don't add another duplicate. I'm actually going to move this to the top. And we're going to have to rework our solution a little bit. So we have a map. Then rather than doing this, if Let's see. Then we want to add next character 1. Otherwise, if it is existing, character set add next character set dot get next character plus 1. So we just increment the frequency. Okay. Then in this while loop, we can say right plus plus, left plus plus, and then, let's see. Before we increment, character set add next, or sorry, we do S on the left, which is our character on the left window, before we increment over it. Character set dot get, we know that it's in there, at S left minus 1. We know that it'll exist in the set because we add the first one in our set. I guess we could rename this the character map instead because it's a map and not a set now. And the idea is that our map stores the duplicate values. We always know if there's a duplicate value. Get or null, or character map get or null next character equals 0. So if the next character is null in the map, which means that we've never seen it before, or if we've seen it before but it's already been pushed away, it's already been slidden over, I guess, then we can add it and we can expand our map to the next character. Otherwise, we just add it to our duplicate set and then we continue to slide. Then at the end, all we do is just return our right minus left plus 1. The reason why we do plus 1 is because our initial left and right are the same, right? 0 to 0. And technically 0 to 0 encompasses one character, which is the first character. So that's what we do. So let's see. So while the right, so before we hit the end, we can just do this, right? Until left. So we go to the end until the right side hits the last element, or the second to last element, and then we do this. We grab the next character, so this will go up until s.size minus 1 plus 1. Or so, sorry, s.size minus 2 because this is less than, plus 1, which is s.size minus 1. So that's always going to have a next character. We check to see if it exists, if either it's a duplicate or if it's a character that we haven't seen before, or if it's a character that we've already gotten rid of before, so we don't have that duplicate anymore. Then we can expand to fill it. If not, then we slide over and we remove our last element. And if this happens to add the last element in our map, then right at that point would be equal to s.size minus 1. And then we would just break out of this loop and return it. So this seems to make sense. And if it encompasses the entire thing, this would be s.size minus 1 minus 0. So s.size minus 1 plus 1, which is s.size, which makes sense if we are encompassing the entire string. So I think this makes sense. And converting or changing from a set to a map hasn't really changed much, though I do just notice that. I don't think that there... Did we miss anything else? Let's see. Get in. So that's character map, character map, character map. That looks all right. We know that this left side will exist. In decrement, because this starts at 1. It all starts at 1, so it shouldn't go under 0. So I don't think we need to worry about that. So I think the solution makes sense. Are there any other edge cases? I guess we could just manually test it here. So here we start at 0, 0. We grab 1, we grab 2. Then we slide because the next one is the same. So we slide and we remove A. So we slide, so we add a frequency here. Or we add, so now at this point, when we, at here we add A. So A's frequency is now 2. We slide over. We remove one element on the left, which happens to be A, so now we're back to normal. Then we check the next one, which is B, and we've seen B before, and it still exists within our map. So we just add B. We set B to 2. We slide again. Same thing with C here. So we slide again. Same thing with B. Same thing with B, and so on. Similar thing here, we increment, and we slide over, increment, and slide over, and so on and so forth. So let's see, how about this one? We start here, we pick up W, right? So now it's 0 and 1. And then we can't pick up this one, so we increment W. And now we have 2 copies of W. Now we have 2 copies of W. We can pick up K. We haven't seen K before. And... ooh. Interesting. No, this wouldn't work. Because if we had this, just this string, PWWK, then our map would start off fine. Pick up W. But then here when we slide over and then we look at the next element, when we look at the next element in that case, then we would say, okay, yeah, the next element we haven't seen before. And then we increment our sliding window to size 3. So what could we do instead? Well, in this case, we could decrement the window. Like we said, I think I was thinking about contracting the window before. So we start here, When we do this increment, what we do is that we contract the window down to size 1 again. So we do right minus minus. So here it would be size 2. And then we push it to size 1, but we'd increment left and right. So in this case, left is 0, right is 1. If we decrease right, then right becomes 0 again. It seems like almost we want to decrement 0 instead to push it forward and then move it. Because in that case, then this would become size 1. So then left and right would both equal 1, and then when we push it forward, we become size, we still stay size 1. So in that case, I think that makes sense. But I want to confirm it with other 0, 0. Right? Then we take a look at the next element. Next element is the same. So what we do is that we set b to 2. Then we remove 1. And then we increment left to here. Maybe it's if left, right minus left is greater than or equal to 1. Then we do that. Because let's say here, this works. We contract it, so we increment p by 1. Sorry, not p by 1. Left by 1, so that it's either still less than or it's equal to the right. And then if we had a situation like let's add another one, right? So we'd start with p, we absorb w, then next value is w again. So we increment left side, we remove the p. Then we need to store the max size. If we're going to be shrinking our array. If right minus left plus 1 is greater than max length is equal to right minus left plus 1. So we do that, absorb that. This next w doesn't work, so we shrink it. So we go from 0 and 1, increment the left, so it's now 1, 1. Still can't absorb that, so we just scooch over. So 2, 2. Still can't absorb that, so 3, 3. Can't absorb this, can't absorb this. Can't absorb this. But now in this case, what do we do? Right minus left is greater than or equal to 1. And we update the max height, or the max length, to 3. Then we scooch over left. To K and E. So we go from WKE. We get rid of that W. And then we scoot over again to EW. This doesn't seem right. The scooting over. We have it here. because we sort of incremented twice. I think we only really want to do that when it's equal to 1. But what would we do otherwise? If we had this, ideally we just shift over, but that gets us the problem that we had before, where if we had this, right, and then we scoot it over, if we had this and we just scooted it over, then we could pick up that, and that doesn't make sense because that's not, because we still have a duplicate in here. So that would be a problem if we had just PWWK, right? Because it'd be that, and then we grab the W. If we didn't scoot it over, then we just slide it over to WW, and then we can pick up K because we haven't seen it before. So it report this as the longest string, even though technically it's only just WK. I'm just trying to figure out how we can handle all these cases with the sliding window. Makes sense to do that. Maybe we still want to do the inner while loop. So while we have that. No, but then we still need to keep on adding our other, we still need to keep track of the other things that we had as we're sliding. So that won't work. We can't just do like an inner while loop and say like, oh, while this is still a duplicate, we just slide it over. No, that won't work. Because there could potentially be other duplicates. Like if I did, let's see, A, B, B, C, 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 B. If I did this, this, can't increment this, and I do, oh, like, while C is still in the string, we increment it, so we increment it to BCC. C is still here, B still here, and we finish. I'm just thinking. Oh gosh. Okay. I'm gonna need some probably additional time off camera to really think about this. Okay. I might have something here. I decided to introduce, or reintroduce rather, the inner while loop with a little bit of a caveat. The idea is that, for example, like PWW kect W. If we have a situation like this, we have PW, and we have another W that's next. We need to essentially shrink the string until the point where we have the offending character on the left side. And the reason, I guess the thing that I guess drove me to think about this is like this, right? If we have a string of size 3 currently, and we have a fourth character that is duplicate, then we can't have a string of size and our character on the left is not the next character. Then we cannot support a string of size 3 even if we shift the window over. Because if we shift the window over, we will still have overlap. So we have to move our left, we have to shrink basically the left side that we know is good until we hit that point. So from here, what we would do is shrink. So WKE, we would shrink that down to KE. KE is fine because the left side is the value. So at that point we can stop. We can shift the entire apparatus left, and we can keep going. So that's sort of the idea, right? So let me actually make this comment here. If the character is not on the left edge, know that the maximum string cannot support the value. The current string length is impossible, even sliding, because of the overlap. So in a case like this, right? We have a case like this. This doesn't work, but the left is the same, so we just increment over, and so on and so forth. With a case like this example, we first grab our 3 characters. Here it's on the left side, so we can just shift over. Here it's on the left side, so we can just shift over. Same thing here. This is not the case. So even if we shift over, we will still have a duplicate. Therefore, we need to shrink our array to something like this. Because no matter what, a string of size 3, because our next character is B, and we know that we have a B somewhere in our current string, but it's not on the left, then we can't just shift it over because it won't get rid of the duplicate. So we need to shrink our maximum by 1 until it is on the left side, and then we can support it. We can support a unique string by sliding it over. So I think this solution works. Let's give it a shot with just the first example, just to make sure that I'm not like missing something. Let's see. This get is not... Oh, that get is fine. Where am I doing s.get? Oh. Just want string at 0. Size? Is size a function invocation? No, I confused it again. Its size is a collection. Length is for strings. Got it wrong again. Oh my gosh. See if it compiles. S0. Inferred type. Mutable map. Apparently pair is a thing. Is there a native pair function in here? There is. Oh, wow. I should have, huh. Okay. Maybe I've used it before and just forgot. It's been a decently long time. I think there's some other way that I could do this, actually. But, getter null. Is getter null not valid? Is it not? Is it? Oh, it's just get. And it returns null by itself. Okay. And it's put, not add. Put stuff into a set and put stuff into a thing, into a map, and you add it to a list. Cast int because yeah, next character. Oh, 0. And same thing here. If it's null, you just 0. This is a little bit messy using the Elvis operator like this, but it works, I guess. Because this get might return null, so you just do that. And just okay. Let's see. 0, 0. Interesting. Did not return the correct value. This character is null or 0. Then you do this. Oh, the frequency. Do we want to add a frequency? At least not after. No, it doesn't matter. It shouldn't matter. So it's left minus right is equal to 0 and 2. Then we don't need to, or we did that, we incremented the frequency by 1 and then we just moved it over. Honestly, I could do this like that. and not worry about this over there. Why is this still not working? Interesting. It is not recording this max length. Or at least not recording it the way that I expected it to. Print line left. Right. Right goes 0, 0. Actually, this should be at the end. Before the slide. Zero, 3, 2. What is going on there? Should be like next character, like it should be pretty consistent. B. Why does it skip C? It just skipped C. Why did it skip C? Oh, because it slid over. In that case, do I even need to do this? Watch as I run into a TLE. Because I'm pretty sure it's grabbing the next one and then just sliding over, right? So that's what's screwing me over. Looks like I am running into a TLE. Yike. So we don't actually want it to slide over, but it seems like we're running into some other issues. Okay. Okay. And then we want to do... Or we could do while character map get next character is not 0. Just slide it to the left and increment it. So this will keep on going. So here now for P, W, and then when we encounter the W, it'll go like, okay, so it's still in here, so here, here, and then we increment 1 again. If we increment all the way to, so we start, it's 0, 1, left and right. Not even, okay, you can see this on the screen. Okay, so it's 0, 1 initially. Then it's 1, 1. Then it's 2, 1 until we get rid of it. And then we want to increment the value here. 2, 1. We increment, we add it. And then we move the right also, so it's 2, 2. So now they're both here. We grab this and this. And now again, we have it exists within our list, so we increment the left. So now it's not in our list. Then we add it, and then we shift our right over. So this seems to be correct. Let's give it another go. Hopefully this time we don't run into a TLE. Ooh, looks like we got an out of range exception. Why did this? We did B, C, and then A. And then this is where we got our out of bounds exception. What? And on line 44, no less. How did this get? How did this get to 8? I'm so confused. How did this get to 8? Character map get is greater than 0. So we know that it's not null. We know that it's not 0. So while it's greater than 0, we do that. This should be no. It should be next character, right? Because we if we just keep on indexing the left side, then we'll no. We should be indexing the left side. Should be indexing the left side. Until this frequency is 0. Just gonna debug everything since apparently the left side is hitting 8? How's this a complex expression? Is it because of my comment? I'm pretty sure it's... I'm like 90% sure it's not. It's just... It's weird. Well, character map. Dot get. Next character. Why is it saying this is a complex expression? Oh, Kotlin, why are you doing this to me? I can get this part. Okay. But why the others? This shouldn't be a complex expression. We've... I'll do a not null first. Still no. That's annoying. Fine, not equal to 0. Oh gosh, what is happening? Okay. Hold on, let me try to fix this issue. Alright, so I think I fixed the issue. The main thing is that it seems like Kotlin is not as smart as I thought. This Elvis operator is a bit dangerous. This basically said if null, then you do 0 minus 1. What I wanted is that this either returns the value or 0, and then you subtract 1. So I wrapped it in parentheses, and it seems to be working now. I just ran it against the 3 example test cases, and it seems to work. So let's toss it through the ringer, and let's see what we get. Okay, looks like we got an issue here with the size 2. Interesting. Okay, looks like if we increment over... Actually, why am I doing that? That's dumb. This is dumb. What if I just move this to the bottom so that every time we increment, no matter what, we just increase the max length if it's a new max, because that's how it should work. It should work against this AU as well now, because we're also checking when we're expanding. Alright, let's actually put it through the ringer this time and hope it works, because all we can do is really hope. Ooh. That is slow. Well, I don't know. Maybe it is. Let me actually check the submission. Yeah, it looks like there's a better solution in about, let's see, I'm at 47. It's like 3 something. Looks like there's a better solution over here. Either that or my solution is just kind of not optimized perfectly. I'm gonna give it a little bit more thought, and I'll come back if something else comes up. Alright, I decided to take a quick look at the ASCII table. It looks like we have, starting at decimal 32 until decimal 126 is all the characters and symbols that we really care about, at least as far as I see English letters, digits, symbols, spaces. Let's hope it is, and let's give it a run. This is actually O1 space then, if this actually passes. It seems like we ran into an out of bounds exception. That's a big string. Wow. Maybe it's 95 then. Yeah, it looks like it was 95. Let's see if this actually passes though. Hey, there you go. Now that's a runtime that I like to see. 98.54% space, or speed, 96.38% space. All because we used ASCII alphabet. Cool. In any case, this took a little bit longer than I expected, but at least I identified the main pattern pretty quickly, which I'm happy about. This sort of logic stuff took me a bit, and then the sort of shrinking of the array and things like that took me a little bit longer. That was about like half an hour in, I would like to say. But in any case, again, there are, I think, mostly two types of medium problems. They're either a new patterns, so for example, the heap problem that I did last episode, or variations of a pattern that we've seen before, like sliding window. And this is the latter one. And just something that just practice a little bit more to understand, like, okay, like this is a pattern. Maybe I need to do some adjustments on to like to sort of see like how to make this, how to finagle this into working properly. But in any case, I hope you learned something, and I'll see you for the next problem.